Hello dear grade 8 students, how are you today? Today I will solve for you extra exercises about polynomial in week 6. In this exercise you will find expand, factorize, solving and areas as well. So it's so important, take care about it. The exercise here, you have MMPQ and ABCD are squares. You have IEFH is a rectangle as given here. And you have to calculate A of x, which is the area of ABCD, B of x, the area of shaded part, and then solving some equations and finding x for which A of x is equal to B of x. So let us start part by part. First part is to find A of x. A of x is the area of the square ABCD. ABCD is a square. To find its area, let us remember the area of square, which is equal to side to the power 2. And the area of the rectangle as well, its length times width. Here we have a square, so we use the area of square, which is side to the power 2. The side is AB, so it's AB to the power 2. And since AB is x plus 3, so it's x plus 3 to the power 2. Therefore, A of x is equal to x plus 3 to the power 2. This is A of x. Let us move to part 2. Part 2, calculate the area B of x of the shaded part. Look at the figure, guys. To get the shaded part, you should find the area of the big square MNPQ, and you cut from this square, you cut a rectangle IEFH. If you cut this rectangle from this square, you get the area of the shaded part. So, to find the area of the shaded part, we subtract. Cut means we subtract. We subtract the area of the rectangle IEFH from that of the square MMPQ. So, area of MMPQ, which is a square, it's side to the power 2. So, it will be MN to the power 2. MN is 6 centimeter as you see here. So, it's 6 to the power 2, which is equal to 36 centimeters square. This is the area of MNPQ, the square. The area of IEFH. IEFH is a rectangle, so it's length times width. Length is 4x given here, and width is x given here. So multiply 4x by x, it will be 4x squared centimeters squared. Now you have the area of the big square, you have the area of the rectangle. If you subtract area of MMPQ minus area of IEFH, you get B of x, which is the area of the shaded part. So B of x will be equal to 36 minus 4x squared. Part 3, you have a function or a fraction, h of x is equal to A of x over B of x. And A of x is calculated before, B of x is calculated before. Let us remember, guys, that a fraction is defined when its denominator is different from 0. Any fraction to be defined, its denominator should be different from 0. Here you will ask to find the values of x for which h of x is defined. So h of x is defined since it is a fraction when its denominator 36 minus 4x squared should be different from 0. To continue, you should factorize this expression. It's a must to be factorized and not expanded. So to factorize this expression, you have to remember that the rule a squared minus b squared is equal to a minus b into a plus b from the remarkable identities. Here you have 36 as a squared, 4x2 as b squared, so it gives 6 minus 2x into 6 plus 2x not equal to 0. Here you have 2 as common, take it outside, and here you have 2 as common, take it outside. So we get 4 into 3 minus x, 3 plus x not equal to 0. And as you know, put each parenthesis not equal to 0. Between them you have to put and. So 3 minus x not equal to 0 and 3 plus x not equal to 0. So x not equal to 3 and x not equal to minus 3. Therefore, h of x is defined for all real numbers at x except minus 3 and 3. This is the domain of definition of h of x. All the real numbers are accepted except two values, which are minus 3 and 3. Simplify h of x. h of x is a of x over b of x. A of x is calculated before, b of x is calculated before, but please use the factorized form of a of x and the factorized form of b of x to simplify later on. The factorized form. So, if you put the factorized form of a of x and b of x, and then you simplify x plus 3 by x plus 3, you get the simplified form of h of x, which is x plus 3 over 12 minus 4x. Whenever you deal with h of x, please, you can deal with this form because it's simplified form of h of x. 3b. Does the equation h of x equal to 0 admits a solution? Justify. Let us remember that h of x is x plus 3 over 12 minus 4x. Put it equal to 0. And then do cross multiplication, x plus 3 multiplied by 1 and 12 minus 4x multiplied by 0. So x plus 3 equals to 0. So x is equal to minus 3. But wait, guys, h of x is defined for all real numbers except minus 3 and 3. Do you remember the domain of definition of h of x? So x is equal to minus 3 is a value excluded from the domain of definition, therefore, which is impossible. So the equation h of x equal to 0 has no solution. Does the equation h of x equal to 0 admit a solution? No, the equation has no solution because minus 3 is excluded from the domain of definition of h of x. Show that 5x squared plus 6x minus 27 equals that form. You can take this form and you do expand to get 5x squared plus 6x minus 27. So yes, it's true. Verify that a of x equals minus b of x equals to this form. Take a of x, which is x plus 3 squared, minus b of x, which is 36 minus 4x squared. Because the answer is expanded, so you do not factorize this expression. You do not try to factorize. All you do is to expand. And to expand this, you have to remember the rule a plus b squared equal a squared plus 2ab plus b squared. If you apply it, you get x squared plus 6x plus 9. And you distribute this minus 36 plus 4x. Take care about this minus times minus, it's a plus. And if you collect like terms, you get the form you're asked to verify. Deduce the value for x of x for which a of x equals to b of x. Here, you start by a of x is equal to b of x. Move b of x to that side of the equation. You get a of x minus b of x is equal to 0. Remember that a of x minus b of x is equal to this form. And this form is verified equal to that form. So a of x minus b of x, its expanded form, here is it. And its factorized form, here is it. And since the second member of the equation is 0, so use the factorized form. So x plus 3 into 5x minus 9 equal to 0. Take each parenthesis aside equal to 0. And then x equal to minus 3 or x equal to 9 over 5. But wait, x is equal to minus 3. And at the beginning of the question, you have x should be greater than 0 because it's a length expressed in centimeter and x greater than 0. So this value is rejected since x positive, since x should be positive, and this value is accepted, and this is the solution of the equation. Thank you, dear students. I hope to see you soon. Take care. Bye.